Welcome to Ask and Learn.
Hi, in this question, we are asked to figure out the formula for this sum over here and then prove that the formula we found is true for any positive integer n. So we are using induction again. First, what should the formula for this sum be? Well, you can look at each term here and see that it can be broken into two terms always. So it will be 1 over the first number minus 1 over the second number always. So until the end here, it will be 1 over n minus 1 over n plus 1, right? And everything in between gonna kill each other out, left with just the first and the last term. So this should be our formula that we found. So to answer the first question, this is the formula for this sum. And we want to prove that it is true for any integer n, positive integer n. So we are using math induction. First, basic step. Oh, sorry. Let's call this formula P of n. Okay. And basic step P of 1. So the left hand side will have 1 terms in the sum. The right hand side is this 1. And it is 1 over 2. So P1 saying that 1 over 2 equal itself, which is obviously true. So we have clear the basic step. Now on to the next, the inductive step. We assume that P of n is true for some n greater or equal to 1. Then we want to show that Pn plus 1 will follow from that. So we want to construct the new statement using the old one somehow. And we can do that. Let's look at this sum. The first n term here is the left-hand side of Pn, right? And since we assume it as inductive hypothesis, we can use that it is equal to this term that we just described. And the last term is, this is the same. So we didn't do anything with it. And then we can break this into two parts as well. So 1 over n plus 1 minus 1 over n plus 2. When we do this, then these two kill each other. And we left with 1 minus 1 over 2, which is essentially what we want for the right hand side of Pn plus 1. Now we have shown that this sum on the left hand side equal to this formula on the right hand side. So we are done. We have shown that we can construct Pn plus 1 using Pn. Inductive step clear. Now with both of these, we have shown that this statement is true for any positive integer n from 1 onward. And that is it. Thank you.